Welcome back to the Tech Learners. Let us understand the next definition in the types of relations. So in the last lecture, we have studied symmetric relation, and today we will understand what we mean by asymmetric relation. Asymmetric relation. Actually, this is the opposite of symmetric relation. Let's define this first. So, a relation, let's write the definition. A relation R defined on a set A, defined on a set A will be asymmetric when for any two elements, let's say x comma y, that are belonging to A, if x r y is true, which means x is related to y, then y r x must not be true, which means for any pair, any ordered pair x comma y, if it is in R, so any ordered pair, let's say A comma B, that is belonging to R, then there must be B comma A should not belongs to R. So this is the condition for a relation to be asymmetric. Let's see this with the example. Let's say if there is a set A, and the set A has the elements 1, 2, and 3, and there is a relation R defined on this set. So let's see if this R is having the elements ordered pairs. Let's call it 1 comma 2, and we have 2 comma 3, and we have let's say 3 comma 1. So if these are the ordered pairs, then let's see whether this is asymmetric or not. So we will check for each ordered pair. Let's say for 1 comma 2, let's say we should not have 2 comma 1, we should not have. So we can see in this relation there is no 2 comma 1. So this condition is true. Then next ordered pair is 2 comma 3. Let's say for 2 comma 3, we should not have 3 comma 2. We should not have. So we can see we do not have even 3 comma 2. So this condition is also true. And the next is, let's say the ordered pair is 3 comma 1. So for 3 comma 1, we should not have 1 comma 3. So we can see that there is no 1 comma 3. This condition is also true. So the condition is true for all ordered pairs that are belonging to R, which means the R is a symmetric relation. Now let us see one more example. If we have this R, for example, let's say 1 comma 2, 2 comma 3, 3 comma 2, if we are having this. So let's check one by one. For first ordered pair 1 comma 2, we should not have 2 comma 1. We should not have. So you can see we do not have 2 comma 1. So this condition is true. For next ordered pair 2 comma 3, we should not have 3 comma 2, but we can see the 3 comma 2 is in, so this condition is false according to the definition of asymmetricity. So we will say that this R is not a symmetric relation. Let's see one more example. If this is R with elements, let's say 1 comma 2, 3 comma 2, and 2 comma 2. So let's check this relation for asymmetricity. We'll start with the first order pair. So in this 1 comma 2, according to 1 comma 2, we should not have 2 comma 1, and we can see in this relation we are not having 2 comma 1. So this condition is true. For next ordered pair 3 comma 2, for next ordered pair 3 comma 2, we should not have 2 comma 3, and yes, we can see we do not have 2 comma 3 in this as well. So this condition is also true. And for the last ordered pair, let's say for 2 comma 2, we should not have 2 comma 2, but we can see that 2 comma 2 is present there. So according to this, condition is false. So we again say that this R is not a symmetric. So what is a symmetric, asymmetric relation? Where for each ordered pair, we should not have, if the ordered pair is of A comma B, then for in any case, that same relation should not have the same relation should not have b comma a. It should not have, right? So this is the example of a symmetric relation. In the next lecture we will understand anti-symmetric relation.